Hello class, today we're going to be talking about transversals, and transversals are, a transversal is a line that intersects two or more lines. So here we have these two green lines, line 1 and line 2, and they're both being intersected at different places by the blue line. And in this situation, we're going to let the blue line be the transversal. So when we intersect, when a transversal intersects two or more lines, angles are formed, as you can see here. And we want to see, is there a relationship between the angles formed at the points of intersection? So as you can see here, F is a point of intersection of the transversal and one of the lines. And D is a point of intersection at the transversal and the other line. So let's take a look and see what happens as we change where F is located on line 1. Do you notice any patterns? For what you should notice is that regardless of where or the slope of this line is, at the point of intersection, 4 angles are formed and the opposite angles are congruent to each other. So this is 140, this is 140, and this is 40, and this is 40. So we call these two angle pairs, we call them vertical angles or opposite angles. And opposite angles are congruent. So underneath the congruent formula, we're going to have vertical angles and opposite angles are congruent. Now let's talk about some other relationships that are occurring here. What happens if I were to take this angle between the blue and the green and the angle between the blue and the green, and they share a common edge? What does the sum of their angles add up to? Well, if you said it adds up to 180 degrees, you're absolutely right. And as I change the slope of the line, will it always add up to 180 degrees? And if you say yes, then you're absolutely correct. So in this case, we have here these two different types of angles, and they are not congruent, but if I add them up together, that means they add up to 180. So we call these adjacent supplementary angles, or we call it a linear pair, which means the exact same thing. Not only do they add up to 180, but they are also adjacent. Now let's see, as I move E and D around, as I move E around, do you think the same thing is going to occur over here at point D? So that's a good question, and what do you think that's going to happen? If you think it is going to be the same, you're going to have vertical angles are going to be congruent, and that adjacent angles are going to be supplementary, then you're absolutely correct. So we've talked about special pairs of angles, vertical angles or opposite angles, which are across from each other. They share a common vertex. And then we talked about adjacent supplementary angles, or angles that share a common side. And we found out that they are also called a linear pair because their angles add up to 180. But there's some other type of angle relationships that are occurring here. One of the type of angle relationships are called alternate interior angles. So an alternate interior angle are angles that are in the interior of the two lines, but they're alternate, which means they're on opposite sides of the transversal. So an example of an alternate interior angle would be 116, the angle that measures 116, and the angle that measures 125. Can we say that this alternate interior angle is going to be congruent? Very good. It's not congruent. Now let's take a look at alternate exterior angles. Alternate exterior angles are on opposite sides of the transversal, but they're outside of the two lines that are being intersected. So here, this angle compared to this angle is alternate exterior angles. And so the question is, do you think that they're going to be congruent? Well, if you said no, you're absolutely correct. These are also not going to be congruent in this example. Now let's take a look at the angles that appear on the same side of the transversal, but inside. So same side interior angles. They're on the same side of the transversal, and they're also called consecutive interior angles. Are these going to be congruent? In this case, no, it's not. And then over here, we have the last pair we want to talk about are the corresponding angles. And the corresponding angles are on the same side of the transversal, but if one is on the exterior of a line, then the other is going to be on the interior of the two lines. So these two angles are corresponding angles because they're on the right side, but one is on the exterior of the angle and the other is on the interior of the two green lines. Okay? So are these two angles congruent? No, they're not. So we have a relationship here. We have 4 different sets of angle pairs, but as we can see, they don't have anything special unique about them. They're not only not congruent, but they're also not supplementary. What do you notice about lines 1 and 2? What relationship do you think is occurring between lines 1 and 2? Are they parallel, perpendicular, skew? Well, if you said parallel, you're wrong. And if you said perpendicular, you're wrong. Because they will intersect, and we can't see out here, but they're not going to intersect at a right angle. So all we can say is that line 1 and line 2 are intersecting. So when line 1 and line 2 are intersecting, we're going to get that these 4 angle pairs are not anything special. But let's see what happens if line 1 and line 2 are going to be parallel. So here I have another set of lines, and this line right here is going to be the transversal. I'm going to color it blue. So here we have these 2 lines, and we have the transversal, which is in blue. And this indication here indicates that these 2 lines are parallel, which means that they will never intersect and they're on the same plane. And the indication here is very important because if we have this indication that they're parallel with these 2 little arrows, that means we don't have to check. Let's take a look at the vertical angles formed by the points of intersection of the transversal and the lines. What do you notice? Yes, the vertical line angles are always going to be congruent. Doesn't matter which pair of vertical angles you have, they're always going to be congruent. And that works whether the lines are parallel or not. Let's take a look at the alternate interior angles. Remember, they are on the opposite sides of the transversal, but in between both lines. What do you notice about that? Even as I change E, it looks like the alternate interior angles are going to always be congruent. Okay? That's good to know. Let's take a look at the alternate exterior angles. They're on opposite sides of the transversal, and one is in the exterior and they're both on the exterior of the lines. And what do you notice? Even as I change the position of the transversal, the alternate exterior angles are also ending up to be congruent. Let's take a look at the consecutive interior angles. They're on the same side. And let's move it over here. What do you notice? Are they congruent? No, they are not congruent. But what would happen if you were to add them together? You would end up getting 180 degrees. So that means that these angles are supplementary. So consecutive interior angles are supplementary. And the last but not least is the corresponding angles. They are on the same side of the transversal, but one is on the exterior of the 2 lines and the other is on the interior. So what do you notice? And if you said, oh, it looks like corresponding angles are also congruent. That's it.